Hey everybody, so in this video we're going to talk about the second part of 2.5, which is absolute value inequalities. Okay, so you should have already watched the video about absolute value equations. Okay, so let's start with an example. Okay, and we're going to start the way we did last time by looking at a number line. Okay. So what we're talking about here is all the numbers whose absolute value is less than or equal to, or just less than 3. Okay, so what that means is that the distance between this number and 0 is less than 3. Okay, so we're going to go less than 3 units away. So we're going to go out to this point, but we're not including this point. Okay, but the absolute value doesn't tell us if we're moving right or left. So we're also going to be going out this direction 3 units, but not including the distance that's actually 3 units. Okay, so here's the numbers whose absolute value is less than 3, meaning the distance between all of these numbers and 0 is less than 3 units. Okay, now that we've drawn these on the number line, we can write these as an interval. Okay, so we can say that they start at -3, and because -3 is not included, we're going to use a parentheses. Okay, and these numbers go up to +3, and because +3 is not included, we're going to use parentheses there as well. Okay, now it's not necessary for this question, but we certainly could write this picture on the number line as a compound inequality. Okay, so we could write that x is between 3 and -3. Okay, now this is going to be useful for our next example, but for right now, this is really just something extra we can do. Okay, let's look at our second example. All right, so let's look at example 2. Okay. All right, so just like with the equations, we want to think about this whole expression as a single number, okay? So we're going to think about that number having absolute value less than 7. Okay, so the distance between this number and 0 is less than or equal to 7. So we could be moving all the way out here up to 7, okay? Or we could be moving this way out to -7. Okay, so one way to describe these numbers would be that they're between 7 and -7. Okay, and remember we're talking about the entire expression 2x plus 1 as a single number. Okay, now that we have these as a compound inequality, we know how to solve this. So we're going to subtract 1. Okay, and then we're going to divide by 2. All right. Now we can see this inequality, and we're going to write that answer as our interval answer. Okay, so between -4 and 3. Okay, and because we have less than or equal to, we're going to go ahead and use the brackets. Okay. All right. Let's go ahead and look at another example like this. Okay. So once again, we're thinking about this whole expression as a single number. Now that number is less than 5 units away from 0. So we're going to move out 1, 2, 3, 4, 5 units to the right, but we're not including that value. And then 5 units to the left. 1, 2, 3, 4, 5. But we're not including that value because it's less than and not less than or equal to. Okay. Now we can see that the numbers we've described here are between -5 and 5. Oh, sorry. Okay, so we're going to say that this whole expression is between, I shouldn't have written it there. Okay, -5 and 5. Okay, and now we can solve this. So I'm going to subtract 3. Okay, and then I need to divide by -1. So now remember, okay, if you multiply or divide by a negative, okay, you have to switch the inequality. Okay, so in this example, when we're dividing by -1, sorry, -8 divided by -1 is 8, okay? Negative x divided by -1 is x. This is why we were dividing by -1 to begin with. And 2 divided by -1 is -2, okay? And we're switching the direction of the inequalities because we've divided by a negative number. Okay, now we can see that this is x between 8 and -2. Remember, when you go to write your interval, the smaller number has to be on the left and the bigger number has to be on the right. Okay, and because we have greater than and not greater than or equal to, we're going to use parentheses. Okay. All right, so 2 things to remember there. One, when you're doing an inequality and you're multiplying or dividing by a negative, you have to switch the direction of the inequalities, okay? Then the second thing is, for interval notation, the smaller number goes on the left and the bigger number goes on the right, okay? Regardless of how they're oriented here, okay? All right, let's go ahead and look at an example with one more step here. Okay, here we go. So the first thing we're going to do is isolate the absolute value part. Okay, just like we did with the equations, we're going to isolate the absolute value. So first I'm going to subtract 7 from both sides. And then I'm going to divide both sides by 2. Okay, now that I've done that, I'm going to think about the number line. Okay, so again, I'm thinking about this as a single number. So the distance between this number and 0 is less than 1.5. So I'm going to go 1.5 to the right and 1.5 to the left. Okay, so you can see from the number line that this number is between -3/2 and positive 3/2. Okay. All right. Now I'm going to finish solving this, so I'm going to add 2. Okay, and then I'm going to divide by 5. Okay. And now I'm going to write my answer as an interval. So my left endpoint is 1/10. My right endpoint is 7/10. Okay, and because I have less than and not less than or equal to, I'm going to use parentheses. Okay. All right, let's do one more example like this. Okay, so the first thing I'm going to do is isolate the absolute value. So I'm going to add 10 to both sides. And then I'm going to divide both sides by -2. Okay. Now remember, because I'm dividing by a negative number, I'm going to change the absolute or the inequality symbol, okay? And this is because I divided by a negative number. Okay. All right. So I'm going to imagine the number line. Okay. Now this number has absolute value less than 1, meaning I'm moving less than 1 unit away. Okay. So I can see that my number is between -1 and 1. Okay. And now I'm going to finish solving this. So I'm going to subtract 2, sorry. And then I'm going to divide by 3. Okay. And now I'm going to write this number as an interval. So my left endpoint is -1, my right endpoint is -1/3. Okay, and because I have this or equal to part, I'm going to use brackets. Okay, there we go. All right. So if you guys noticed, all of the examples that we've done so far have been with the absolute value being less than something. So now we're going to look at an example where the absolute value is greater than. Okay. So let's look at one of those. Okay. So we're going to look at first the number line. Okay. So this is telling me that the distance between this number and 0 is greater than 3. So first I'm going to go out to the distance where it's 3. Okay, so here's where the distance is exactly 3. So I want to be further away from 0 than this. So this is where it's further away. Okay, and I can see that this is corresponding to x is greater than 3. Okay, now I'm going to go in the other direction. Okay, so when I go out this way 3 units and then I look further away, that's going to be over here. Okay, and you can see that this corresponds to the numbers where x is less than -3. Okay, And now we're going to write this as an interval. So this part of the interval goes out to the left forever. So it's going to go negative infinity up to -3. Okay, and we're going to use parentheses here because you always use it with infinity, and here because we have just less than. Okay, and on this side, we can see that our interval starts with 3 and goes off to the right forever. So we're going to go to infinity. And again, we're going to use parentheses. Okay, now because we have these two intervals and they don't touch, we are going to unite them with the union. Okay, so that would be our answer here. All right, let's look at a slightly more complicated example. Okay. All right. So first I'm thinking about what numbers have absolute value greater than 2. Okay. So again, I'm thinking about this whole expression as a single number. So if the absolute value is greater than 2, I'm talking about this part and this part. Okay. So this is that number. Okay. The whole number is less than -2. Okay. And this part describes that whole number being greater than +2. Okay. Now, something very important that I want to instill in your mind, okay, you cannot combine these. Okay, it is just not possible to combine these two inequalities into a single inequality, and it's because of what you see here. There are two disjoint parts of this, so you can't combine them into a single part. Okay, before we were looking at a single part, so we had a single inequality. Here you have two different parts, so you need two different inequalities. Okay, so let's go ahead and solve them. I'm going to subtract 1, that gives me 3x is less than -3. And then I'm going to divide by 3, so x is less than -1. Okay, then I'm going to go ahead and look at this one. Okay, I'm going to subtract 1, so I get 3x is less or is greater than 1. Okay, and then I'm going to divide by 3, so x is greater than 1/3. Okay, now you may or may not need to look at the number line to write the interval notation for this. Don't be afraid to look at the number line. Okay. Okay, so x is less than -1, that's going to look like this. X is greater than 1/3, that's going to look like this. Okay, so my interval is going to be -infinity to -1, union 1/3 to infinity. Okay. All right, let's look at another example like this. So we'll call this one part A. Okay. All right, so again, Okay, we're looking for something where this whole number has absolute value greater than 7. So if it's further away than 7, we're going to go out to 7 and go further away from 0, so out this way. Okay, then we're going to do the same thing in the opposite direction. We'll go out 7 units away from 0 and then point further away. Okay. Now we can see that this is going to be these numbers over here. So this number, right, is less than or equal to -7. Okay. Or we're talking about these numbers over here. So this number is greater than or equal to 7. Okay. Now we're going to go ahead and solve these. So I'm going to add 3 to both sides and then divide by 2. Okay. Then over here, I'm going to add 3 to both sides and then divide by 2. Okay. So again, don't be afraid to look at the number line if you need to write the interval here. Okay. So if we are 1, 2, 3, 4, 5. Okay. So if we're looking at x is less than or equal to -2, we're going to start at -2 and go less than or equal to. And then x is greater than 5, we're going to start at 5 and go greater than. Okay. So when we go to do the interval, we can see that this is -∞ up to -2. Okay. And because it's less than or equal to, we're going to use a bracket. Here we're starting at 5 and going off to infinity. And again, because it's or equal to, we use a bracket. Okay. All right, let's do one more example with this, and then we'll do some examples where it might be kind of tricky to tell which one we're talking about. Oops. Okay. So the first thing we're going to do, just like we do with all the absolute value equations and inequalities, is we're going to isolate the inequality. So I'm going to add 2 to both sides. Oops. You add 2, you get 9. Okay. And then I'm going to divide both sides by 3. Okay. So now I'm looking at what numbers have absolute value greater than or equal to 3. Okay, so I'm talking about going where the absolute value is 3, and then I go further away than that. Okay, here where the distance is 3, and then my distance is further away than that. Okay, so these numbers are going to be less than or equal to -3. I can see those numbers here. And then for this part, I can see that I'm talking about the numbers that are greater than or equal to 3. Okay. Now to solve these, I'm just going to subtract 5 from both sides. Okay. And then to help me write my interval notation, I'm going to look at a number line. Okay. Okay. So x is less than or equal to -8, so I'm going to go here to -8 and go less than. Okay, or x is greater than or equal to -2, so I'm going to go to -2 and then go greater than. Okay, so this part of my interval is going to be -∞ to -8. Always use parentheses with -∞. And here it has or equal to, so I'm going to use the bracket. Okay, here I'm starting at -2 and going off to +∞. Always parentheses with infinity. And because I have the or equal to, I'm using the bracket here. Okay. All right. So now we've seen some examples of when the absolute value is greater than or when the absolute value is less than, okay? Now, I encourage you when you guys do these problems to really think about the number line and what the absolute value means as a distance, okay? And let me show you some examples where that's especially important. Okay. Okay, so the first thing we're going to do is isolate the absolute value. So we're going to subtract 2 from both sides. Okay, and then to get rid of the negative 1/2, we're going to multiply both sides by negative 2. Okay, so negative 2 times negative 1/2 is positive 1. Okay, negative 2 times negative 2 is 4. And remember, whenever you multiply by a negative number, you're going to change the inequality symbol. Okay. So now we're thinking about numbers whose absolute value is greater than 4. Okay. So we're going to go out to where the distance is 4, and then we're going to go further away than that. Okay. We're going out to where the distance is 4, and we'll go further away than that. Okay. So we're talking about this number. Okay. And over here, we can see that this number is less than negative 4. Okay. And over here, we can see that that number is greater than 4. Okay. So let's go ahead and solve this. I'm going to add 1 to both sides. Okay. And then divide by 2. Okay. Here, I'm going to add 1 to both sides. And then I'm going to divide both sides by 2. Okay. So now let's look at the number line to help us write our interval. Okay, so negative 3/2. Okay, and it's going to be less than negative 3/2. So we're going out to negative 3/2, and then we're going to go less than. Okay, x is greater than 5/2, so we're going to go out to 5/2. 1, 2, 3, 4, 5. Okay, and then we're going to go greater than. Okay, so when we write our interval, we can see that it's negative infinity to negative 3/2. Okay. And 5/2 to infinity. Okay. Now, I want to make a point here. Sometimes students think that they can memorize a way to do this so they don't have to think about the number line. Okay. The issue here is you're ending up with 2 pieces, but this is a less than sign, and that normally fools any memorization type scheme that people could have, okay? So it is really better to just think about the number line and the absolute value as distance than it is to try to memorize how to do these problems. Okay, let's do one more example. Okay, so again, we're going to start by isolating the absolute value. So I'm going to add 4 to both sides. About my 1. Okay, so negative 13 plus 4 is negative 9. Okay, and then I'm going to divide both sides by negative 3. Now, because I'm dividing by a negative number, I have to switch the inequality symbol. Okay, now I'm going to think about the fact that I have this being greater than 3. Okay, so if I look at the number line and my distance is greater than 3, okay, I'm thinking about these numbers out here that are further away than 3, or these numbers out here that are further away than 3. Okay, so this would tell me that the number I'm interested in, which again, we're thinking about this as one thing. So this thing is less than or equal to negative 3, or that thing is greater than or equal to 3. Okay. Now I'm going to solve this. I'm subtracting 1, subtract 1. Okay, and then I'm going to divide by negative 6. Okay, now it's important that you remember you're dividing by a negative number, so you're going to switch the inequality symbol. Okay, and then I'm going to reduce this fraction. I'm going to do the same thing over here. I'm going to divide by negative 6. Okay, and then I'm going to reduce my fraction. Okay. All right. So this says x is greater than 2/3, and oh, I forgot to switch my inequality here. Okay. When I divided by a negative number, okay, you should be switching in the inequality. So it should switch from greater than to less than, and the same thing here. Okay. All right. So when I look at my number line to write my interval, okay, x is greater than 2/3, so I'm going to go to 2/3 and then go greater than. Okay, and here I have x is less than negative 1/3, so I'm going to go to negative 1/3 and go less than. Okay, so you can see that this interval is going to be negative infinity to negative 1/3. Okay, because it's less than or equal to, I'm going to use a bracket. Okay, here I start at 2/3 and go to infinity, bracket, always parentheses with infinity. Okay. All right. These types of examples can seem easy when you're watching someone do them, but they can take a lot of practice to get right on your own. So I encourage you guys to practice, and I will see you guys soon.